Hi, welcome back, and right now I'm going to be solving the USACO 2020 to January contest silver problem 2 loan repayment. And just a heads up, this problem can kind of seem pretty complicated, so pay attention. Farmer John owes Bessie n gallons of milk up to 10 to the power of 12. He has to give her the milk within K days. So n gallons of milk given within K days. However, he doesn't want to give the milk away too quickly. On the other hand, he has to make forward progress on the loan, so he must give Bessie at least m gallons of milk each day, up to 10 to the power of 12. Here's how Farmer John decides to pay back Bessie. He first picks a positive integer x, so Farmer John picks an integer x, and then he repeats the following procedure. So if Farmer John has already given Bessie g gallons, compute n minus g over x rounded down. So n minus t, since n is the number of gallons of milk, n minus g is basically just the amount of milk left over that Farmer John still has to give to Bessie. And we divide this by x and round it down. And if we call this number y and it's less than m, then we have to set y to m, and then we have to give Bessie y gallons of milk. Lastly, determine the largest x such that if Farmer John follows the above procedure, Farmer John gives Bessie at least n gallons of milk after k days. So determine the largest value of x such that Farmer John gives all the milk to Bessie. Okay, so there's only one line of input, which is n, k, and m. Here we can see in the sample input that n is 10, k is 3, and m is 3 as well. So let's take a look at the sample output. So for the first test case, it says that when x equals 2, Farmer John gives Bessie 5 gallons on the first day. Let's check this if it's true. Farmer John needs to go give Bessie 10 gallons of milk. And if x equals 2, we're dividing 10 minus g, which is, for now, it's 0, since we haven't given any milk to Bessie yet. 10 divided by 2 is 5, so Farmer John gives Bessie 5 gallons of milk. And then we're left with 5 gallons of milk still left remaining to give to Bessie. Afterwards, we divide that by x again when x equals 2. And get m equals 3, because since 2 is less than 3, we have to set the value of y as m. And since m is 3, we set it as 3 on the next 2 days, so Farmer John pays 11 gallons back in 3 days. So let's think about this again. So Farmer John just wants to give Bessie n gallons of milk within k days. And there's this procedure that he follows that gives Bessie the certain amount of milk. And he wants to find the largest x such that he gives Bessie at least n gallons of milk. So basically, he wants to spend as much time as possible giving the milk to Bessie. So in this video, I'm going to be solving this problem using a method called the binary search algorithm. And I'm going to use the binary search algorithm to first test find the optimal values of x. Okay, so I'm going to be checking all values of x, and I'm going to see which value of x is the most optimal. But the question is, how do I check how how many days and how many gallons it takes for Farmer John to give a certain amount of milk to Bessie, given an integer x? Well, this is kind of difficult to explain, so for now I'm going to write it down in code. So first I'm going to write down the binary search algorithm, and then we can work on the check together. the check portion together, where we're going to find how many days it takes for Farmer John to give Bessie a certain amount of milk given a certain number X. So first of all, I'm going to start off with a binary search algorithm. And if you guys are aware of this, a binary search algorithm is basically just a really way to find a specific number that meets our criteria. So our criteria is we're trying to find the largest value of X that satisfies the procedure, right? So first I'm going to set everything up, and I'm also going to be I also imported the Java util and IO classes. Then we need a scanner. I'm just going to use scanner since it's three integers. Actually, it's three longs because each can be up to 10 to the power of 12. We need a print writer, print out the output, but we also need longs n, k, m, and answer. So first, I'm just going to create the standard algorithm for a binary search. You have to initialize the scanner. For now, for debugging purposes, I'll set it as system.in and n equals in.nextLong, k equals in.nextLong, and m equals in.nextLong. So, so that's basically the initialization, and now I'll get to the binary search. And what the binary search does is it there's going to be a certain range that the value of x can occupy. And this is going to be up to the value of n, because technically Farmer John is able to set the value of x as n and give all them um, and give and start giving start uh, the value of y as 1 automatically. So we set an integer value low, which is the minimum possible value of x, as 1, and integer high, which is the maximum possible value of x. Actually, it has to be a long. Both have to be long. Uh, the highest possible value of x is just n. And so what we're going to be doing is we're going to be looking at the value right in between low and high. So the average or the middle of the two values. And then we're going to be checking if this value allows Farmer John to give Bessie at least n gallons of milk after k days. And if it does, what we can do is um, we can change the range of the function, since now we're going to start looking for larger values of x. But let's say that this value of x doesn't work. That means that Farmer John has to decrease the value of x in order to find one that works. So then we change the range of low and high. So I'll show this right now. Also need a long middle, and middle is going to be the average of the two, which is low plus high divided by 2. And a check mid, which is going to check if Farmer John needs to increase or decrease the value of x. And answer equals mid, which means that it does work, and Farmer John can start looking for higher values of x. So low, we change the low value so that the range becomes larger values of x. And then else, we're looking for lower values of x, so high equals mid minus 1. And we just print answer. Then, now here's the really difficult, the more difficult part about this problem. Now we've established the binary search algorithm, which helps us find values of x extremely quickly. But the problem is, even if we have a fast way to find the optimal value of x, we have no way to check how many days Farmer John gives at least n gallons of milk to Bessie. And we don't have a really clear way, since n is going to be 10 to the power of 12 and m is also going to be 10 to the power of 12. So we can't utilize a for loop that uses n and m. I'm going to create a function where it takes an x and it basically repeats this procedure that Farmer John has created for Bessie. And the thing is, what we want to do is we want to maximize the efficiency of this function. So what I'm going to do is, for now, I'm just going to create a standard while loop that does exactly all these 3 steps every day. And from there, I'm going to start making it more efficient little by little. So first, the amount of remaining gallons of milk is going to be n, and the amount of days that are left is going to be k. Okay. And while day is greater than 0, which means that there is still days left, or the amount of milk left that Farmer John has to pay Bessie is still remaining. It's still greater than 0, and remaining is greater than 0. Then what we do is we set a value of y, and instead of subtracting some sort of number g from remain, we can just do remain, and then subtract a certain value from remain as we go along. And if y is less than m, then y equals m, right? And then we do day minus minus, since 1 day has passed, and remain minus equals y. That's basically the entire thing if we ignore the fact that day and remain are going to be 10 to the power of 12. And so yeah, let's think about it now. Since day and remain are going to be n and k, which are both 10 to the power of 12, this while loop is going to take way too much time to compile. So we're going to have to think of a different way to do this. We can keep this general while loop, but what we want to do is we kind of want to skip some values in the middle where the values of y are going to repeat. And so let's try to look for this. In the problem, it says that y is going to be n minus g over x rounded down. And a hint we can automatically gain from this is that n minus g over x is going to be, quote, rounded down, which means that some values of n minus g over x are going to be different when they're expressed in the double form, but they're going to be the same when they're rounded down to the integer form, or the long form in this case. So what we want to do is we want to see which values, we want to see how many, which days can produce the same numbers y. And a formula we can use to do this, if you think about it, if we want to know how many days have the same value of y, these days, okay, so when they're divided by x, when n minus g is divided by x, when n minus g is going to be divided by x, there's going to be a remainder, right? And as long as this remainder exists, that amount of a certain amount of days are going to have the same value of y. And when we divide this remainder by y, we can actually get the number of cows that have the same amount of same y value. We can get the amount of days that have the same y value. So if you think about it, the days here, let me show this like in a spreadsheet. Give me a second to like think about this. So if remain is equal to 17 and x equals let's say 3. And first of all, we're gonna be subtracting 5, right? So it's gonna be 12. Hmm, what's a good number for this? Okay, so let's say x equals 10, okay? Yeah. And let's say that the integer remain is right now at um 19, okay? Let's say x equals 12 actually to make it easier. So if x equals 12, when we divide remain, which is n minus g divided by x, and we round it down, we get 1. So we subtract 1 from 19 and we get 18. It turns out that 18 divided by 12, rounded down, is also 1. So we go 17. And what we do is we keep on repeating this process up until 12. And then when it's 12, we end up with 11, but we can't do 11 since that's... Oh wait, no, we can do 11 since we don't know the value of m yet in this specific scenario. Sorry. See if I can fix this. Okay. But when the value of remain turns into 10, that means that when the value of remain turns into 11, 11 divided by 12 rounded down is going to be 0. So at this point, the pattern stops. And it's going to stay at 11 since we don't know the value of m yet. But the thing is, we can see a pattern here, and in that each of these numbers are all decreasing by 1. And what we want to do is we want to find some kind of formula that finds out how many of the next days are going to have the same value of y. And if we can find this, we can just skip over these values and just calculate it. So how do we calculate the number of the days that have the same value of y given a specific integer remain and x? Well, what we can do is we notice that 19 divided by 12 is going to be 1. It's going to be 1, right? And this value means that 19 over 12 is going to have a remainder of 7. Since it's going to have a remainder of 7, we can then divide this remainder by we can divide the remainder by the rate in which this number is decreasing. So we can divide 19 mod 12, which is 7, by the rate in which remain is decreasing, which also happens to be 19 over 12 floored, which equals 1. So 7 divided by 1 equals 7. And then since we are also counting the current one, we have to add 1. Add 1 since we are counting the current day. And we get 8. And we can check this. 19, 1, 2, 3, 4, 5, 6, 7, 8. And for 8 days, it's going to be decreasing by the same remainder. By the same integer y. So if we implement this in our code, what we can do is basically set long same, which is the number of same days equals remain modulus x divided by y, which is the rate of change in which the integer long range is decreasing, and then we add 1 since we're going to have the current day included. And we can do day minus equals the number of same days, right? We're not just doing minus minus since we're going to be skipping multiple values. And the remain minus equals y times same days. And this would also work if, let's say, we aren't going to be skipping any. So we would still calculate this. And while this does significantly improve our time, there is still one last thing that we can improve, which is that when y is less than m, here, let's see the problem again. So if y is less than m, set y to m, but we see that since n minus g, the number of remaining days, is only going to be decreasing, as the days go by, the number y is also only going to decrease. So if y is less than m at one point, it's always going to be less than m for the rest of the days. So if y is less than or equal to m, so from the first day that y is set to m, then what we can do is we can just return m, which is going to be like what we set y to if y is less than m times the amount of remaining days, since all these days are going to make Farmer John give Bessie y gallons of milk, and then add this, and then we compare this to the amount of remaining milk. And if this is greater than or equal to the amount of remaining milk, that means that Farmer John um, can successfully give all the milk to Bessie. Why is there an error here? It's already defined? Is this being okay? That's very strange. Okay, it went away somehow. Okay, so 10, 3, 3, and we get 2. Yeah, I'm not. This should work for all the test cases because, yeah, it's worked before. New file reader loan.in equals new print writer loan.out. And yeah, that's basically it. We print it out answer at the end, and we close in and we close out. Just so we save the files. Now let's try submitting it. Hopefully it works. Grading in progress. Nice. Nice. Okay, yeah, it passed all the test cases, and here's the code again. So you can see I'll scroll down slowly. So you can pause the video anytime you need to. And yeah, I hope this idea helped you guys. We used a binary search algorithm, and then we skipped over values, and then in order to decrease the amount of time in our check function. And yeah, thanks for watching, and I hope this video helped.